This is an activity on triangular numbers. The objective of this activity is to explore and identify the pattern of triangular numbers and understand their relationship in a sequence. So let's first understand what is the concept of triangular numbers. If we use marbles or pebbles, or you can use even stones, you place a stone like this. This is one stone and one forms the first triangular number. Now I want to place more stones below this like this so that we get an equilateral triangle. And how many stones have we placed here? We have placed 3 stones, and so 3 forms the next triangular number. If I want to increase the side length of this equilateral triangle, I'll have to keep placing more stones below the second row. The third row will contain 3 stones like this, and we will have another equilateral triangle. Now if you count the total number of stones used to make this triangle, these are 6 stones, and therefore 6 forms the third triangular number. In the same manner, we can go on and keep on placing more stones in next row to increase the next triangular number, and as a result the fourth triangular number will be 10. Now this pattern 1, 3, 6, 10 and so on is the pattern of triangular numbers. How do you find that in the 15th triangular number, how many such stones have to be placed? There is a general formula for that, and the general formula for that is n times n plus 1 upon 2. So if I want to find how many stones will be used in the 15th triangular number, or what is the 15th triangular number, I just have to put n equal to 15 in this formula, which will give me 15 times 15 plus 1 16 upon 2, which is 15 8s are 120, and this forms the 15th triangular number. So in this activity we'll be performing the experimental verification of triangular numbers using some colored beads or buttons, or you may use pebbles or marbles, whatever is available readily. We have to use some paper sheets and obviously the marker, the pencil and the ruler, the general things which are available in the geometry box. So let's see how this activity is to be performed.
So as you can see here, I have taken some pebbles for demonstrating how the triangular numbers are formed. I have drawn the observation table here, which is given in the lab manual. It shows the first column as n, then dots in each row, and then the total number of dots, and then the formula calculation. So let's use these pebbles to make the triangular numbers. First of all, I am going to use only one triangular number. Now this is the first and the most basic triangular number. So if I write n equal to 1 here, there is only one dot or one pebble, and therefore the total number of dots, it is also 1. Now when I do the formula calculation, when I take n equal to 1, this will be 1 into 1 plus 1 by 2, and that will be 2 upon 2, which is 1 itself. So 1 is the first triangular number. Likewise, if I add 2 more pebbles in the next row, making the next triangular number, you can see this is a shape of a right equilateral triangle. So how many total dots or total pebbles can you find here now? You can find that there are 2 rows and there are total 3 pebbles, and so total dots will increase to 3, but n, that is position, will be 2, right? So dots in the row, this will be 1 in the first row and 2 in the second row. Formula calculation, you just have to put n equal to 2 in the formula, n into n plus 1 by 2. So 2 into 2 plus 1 by 2. So the 2 cancels out and you get a 2 plus 1, which is 3. That is the next triangular number. Now for the next triangular number, you need to make one more row like this. And now you can see again we have an equilateral triangle, but this time there are 3 rows and the dots in row, the first one contained 1, the second one contained 2 and the third one contains 3. So the total number of dots now is 6. Can we approach this number 6 triangular number using the formula calculation? Obviously yes. Just put n equal to 3 in the formula. So 3 times 3 plus 1 by 2 is 3 times 4 by 2, 12 upon 2, that is 6. And you can see the formula also verifies that 6 is the next triangular number. Now coming on to the fourth part, I am using 4 more pebbles here to make the next row like this. So you have to arrange them like this and this will give you another equilateral triangle. Now how many rows are there? There are 4 rows, so the value of n will be 4 now, and the dots in row now 1 plus 2 plus 3 plus 4, because I have added 4 more pebbles here. So if you add them you get 10, which happens to be the next triangular number. But if you want to verify that using the calculation, then 4 into 4 plus 1 by 2, that is 2 cancels 4 2 times, so you have 2 times 5, which is 10, and that verifies that these triangular numbers 1, 3, 6 and 10 can be obtained using this formula calculation, n into n plus 1 by 2, and that completes our activity on triangular numbers.